Hi friends, welcome to my channel. Let's have a look at problem 890, find and replace pattern. So this is a daily challenge problem. So in this video, we're going to share a solution based on index decomposition. So we feel that this method touches the essence given the problem context. So this problem asks us to find those words which matches the pattern. So the pattern is a given string. So these two paragraphs actually explains what's called match. So I feel personally that these two paragraphs actually makes this problem complicated. So or simplify the real situation. So here are two examples. So in example 1, so we have a pattern ABB and the corresponding output is MEE and AQQ. So you can make a correspondence like the letters explained here. So in example 2, so the string pattern is a single character pattern. So we return all the words. So the constraints on this problem actually is the following. So the pattern length is bounded above by 20 and the words length is bounded by 50. So it's actually not a large number. So we can solve this problem even by brute force. With that said, let's look at the method here. So we hope that we can reveal the key points here. So the method we are going to consider is index decomposition. So we'll explain what's the index decomposition. So here basically it's related to what's a match in the problem context. For example, AQQ and ABB is a match. So if we look at the index, we see A corresponding to index 0 and Q corresponding to index 1 and 2. So if we look at this and make them as tuples, so actually the corresponding decomposition is 0 and 1, 2. So similar for ABB, so A corresponding to index 0 and B corresponding to index 1, 2. So if we look at the decomposition, it's 0 and 1, 2. So actually for this problem, for match, we do not care about the details, how the letters make a bijection or one-one correspondence, right? So this is actually the first example. So let's dive a little bit deeper. For example, we have this string AQQ AA and CBB CC. So if we look at the decomposition of the indices, index the character A corresponding to 0, 3, and 4. So this is the tuple, and the Q corresponding to index 1, 2. So this is another tuple. And then if we look at the second string CBB CC, so the decomposition so is also 0, 3, 4, and 1, 2. So, but the difference lies in the following. So in the first example, 0, 3, 4 corresponding to character A, and 1, 2 corresponding to character Q. And in the second string, so 0, 3, 4, the same tuple corresponding to letter C, and 1, 2 to letter B. So if we would like to do a match, so A corresponding to C and Q corresponding to B. So this is the 1-1 correspondence, or the so-called bi-injection. So with that said, I guess so a solution to this problem is very straightforward. We do the index decomposition and then compare if the words has the same index decomposition with the pattern. If so, they match, otherwise they do not. So with that said, let's do this task. First, I'm going to write a hyperfunction to make this solution modularized. So I'm going to call it partition. So the input will be the pattern or the word. So for this, I'm going to use a collections default dictionary, but it's not necessary at all. But I just need to write it for convenience here. And then we're going to iterate, right, for I character in enumerate pattern. Then we're going to append the current index, so to the list corresponding to the key character. So this way, actually, this in each of the list, actually the corresponding index is also in increasing order. So with that said, we're going to do the return. So we are going to return the decomposition. Actually, so these two match as long as the decomposition are the same, right? So we can regard it as a set, or we can regard it as a list of tuples. Both are okay. So here I'm going to return a set. So I'm going to make a tuple v for v in d values. So that's it for this hyperfunction. So actually next we're going to prepare the return. So this is also straightforward. First, we have a reference pattern, that is the reference decomposition. So we can call it partition for the pattern string. Next, we're going to initialize a list, which is to hold the words. And then we're going to do iterations for word in words. And then we first get the index decomposition for word, and then compare if it equals the reference decomposition, right? If so, then we're going to add this word to the result. And afterwards, we just need to return the list. So that's it for this problem. So as a routine, let's first do a special case check. Yeah, it passes a special case. Now let's do a generic case check. Yeah, it passes all the generic cases. So if you are not, you are still worrying here, so you can make such returns. So return, say, sorted d values, and then do comparison. So this way you will get something like this, 0 and 1, 2. But here it's a list. It's still okay. So let's try this. So, but I would say that the first return here actually is more near to the essence of the logic, or the logic of index decomposition. So with that said, I guess that's about it for this specific problem. Thank you so much.